Yeah,
Okay, great.
cool. So, there were two items today proposed by Federico. So, Federico, the floor is yours if you want.
Yeah, thank you, Jeremy. I think actually, this is, what I'm proposing to discuss. If you guys want, I would very, very much appreciate your feedback and your help on the basics of introducing linear algebra in standard lib. The idea is that I already started to work on more like the high level API, and I'm doing that on a separate repo because I can just prepare the tests and do this stuff quicker than on standard lib. And also because if I can make different PRs and prepare different PRs on standard lib that are more digestible, I think it's better because of course they're all going to be pretty large, but if I can basically break that down into pieces that are easier to read and understand, I think it's better and can get things going faster. So what I was proposing tonight is that I wanted to show you basically the two PRs that I prepared on. One of them is sort of what I call like the version 1.0 of the BLAS and BLAPACK backend merging into standard lib. And the second one is basically the error handling derived type, the state handling derived type for the linear algebra subroutines. So I basically tried to collect, all your suggestions, which, by the way, great suggestions, particularly about the pure functions. And let me start showing you something. So maybe I think it's easier to discuss. And by the way, do feel free to interrupt at any times. Like, I tend to speak for a very long time. I saw that, last month's presentation was cut off at some point. So absolutely do feel free to interrupt me. Let's see if I can share the screen. Screen sharing. Share screen. All right. Can everybody see the screen right now?
No.
No. Let's try again. So share screen, yes. Do you guys see anything? Oh yeah, now I can see the screen.
Yeah.
So it's okay, great. Okay, so going to the standard lib page. Okay, this is the PR that discusses, basically the merging of the backends into standard lib. There were a few updates that I wanted to show you. Right, we had been discussing about OpenMP, and I think that was a very nice addition. Thank you, Jeremy, for proposing that. I actually did not know about this conditional compilation markers that can be used with OpenMP. I think that definitely looks like more clear, and it doesn't really need any preprocessor specific macros. So that was a very nice addition. But what I wanted to show you first, and let me see if I have, I don't know, I'll pick an example here. For example, the double precision LAPACK view file. Yeah, the syntax is not very nice because it's pretty large, but let me see if I can show you how I made the pure routine. So let me just use my editor, so it's going to be easier to visualize. Okay, this is single precision BLAS, for example. It's already pre-processed, so we see the Fortran file actually. I modified the generation script so that now basically all the functions have been made pure. And I think for BLAS, everything is really pure. So pure subroutine, pure functions, but not 100% of them. For example, if I look, I think I was working on the SVD this week. It's called the DGESDD, I think. Yes, and I pick, for example, this is just one of the examples where the subroutine could not be pure, could not be made pure. I basically added a pretty simple tracking of the dependencies in the generations in the Python script that I use to generate this stuff. So basically that tracks down whether, this subroutine, for example, calls other functions like lsame or other procedures in the module, for example, and it tracks them down to see whether all of them are pure or not. And in case there's anything that is not pure, then the upstream subroutine will not be made pure. I actually tested that because I found that in some cases things were not trivial, but it all boils down to some subroutines, which right now I don't remember if they were from LaTeX or BLAS, but some of them have intent out arguments. So there is literally no way you can make them pure anyways. I think if I track intent out, for example, I should be able to show you that there are some functions that really have intent out arguments, and there is really no way we can make those pure. Let me see if I can find them in BLAST, for example, because that would be easier. Intent out. This is subroutines. No, in BLAST, as I said, there is no functions that are not pure. So how can I search for functions that are not okay, well, anyways, most of the subroutines and functions are pure, but of course, some of them are not. So in the most complicated, routines, for example, the SVD one was one of them. When they call functions that are not pure, then, the subroutine cannot be made pure. But I think it's a minority, it's a lesser number of cases. Most of them, as you see, as I'm scrolling here, have been made, pure. I could not make elemental ones because most of them have basically array parameters. So I did not spend, I didn't even spend time to try to make them elemental, but, all of them are basically pure. And in order to ensure that, the biggest change that I had to introduce in the repository was the error handling, which, by the way, was really not being used. And I think, if you use an external implementation, they also don't stop the program when something wrong happens. So I basically just removed the part that was stopping the program. What it was doing here was basically just checking for the parameters, and it wasn't even printing a message. It was basically stopping the program when info was I think greater than 0. No, maybe just different than 0, but anyways, so I made this pure by basically removing the stop statement, because the idea is we're going to have different error handling ways, so we never want BLAST to stop the program whenever something is going not the way we want it. And this is basically the only change that I had to put into the original code in order to make sure that everything could be made pure, because basically this subroutine is called almost everywhere in the library. Anyways, long story short, I think the final interface looks pretty good right now, because most of these routines, as I said, except, for example, the SVD part, which is exactly this interface, these are not pure subroutines. But if you look at most of subroutines and functions, it's basically the whole library, most of the library. One thing that I was, thinking in order to basically make some of these subroutines pure was maybe we could replace functions with subroutines so they could be made pure, but then we would break the interface. Because, these functions are part of, many implementations. So if we change the interface to one of these procedures to make that, to turn a function into a routine, I don't think it's a good idea. I don't know, do you have comments on this?
For me personally, it wouldn't be that much of an issue in the sense that if we are consistent, so everything is a subroutine, for example, yes, existing code, if someone tries to do a drop-in replacement, it's not going to be ideal, but at least the user will know that they always have to deal with a subroutine and they won't have to worry about whether or not it's a function or a subroutine. But fundamentally, I think the existing version is quite good, so I wouldn't worry about removing functions and converting into subroutines, or vice versa, generally.
I mean, this is the problem that plagues every software project at some point, right? That you want to make a backwards incompatible change because it's a much better interface, but it's just harder with Blaz or Lapak because like everything in the world is built on top of them.
Right.
But that doesn't mean like if we're writing something new, we can't be backwards incompatible. If it really is better.
Well, you know what? Maybe one thing, I'm not sure how much work that would take. One thing that maybe could make sense is, as long as there are functions, for example, I found this one. This is one of those that are not pure because it contains, intent out or in-out arguments, right? So one option would be to take these functions, down the, at least those down the dependency tree, turn them into subroutines, which would be pure at that point, and maybe also keep the non-pure function interface. So in other words, duplicate the code, put it into subroutine, keep the function interface that just calls the pure subroutine, but the interface is not pure. But you still want to keep the backward compatible interface, such as this one, for example. I have no idea what this does. This key or condition number of this stuff here. So that whenever in the code this function is being called, replace the call to the function with the call to the subroutine, which now would enable you to make the upstream subroutine pure and so forth. Now, to do this, maybe I think it will require, to check how many of these routines we have and see how long would that take. But I think, yes, this might be an option, and would say, both things, like, the interface compatibility with the original LAPAC and making everything pure, basically.
Yeah, I like that idea. That's a strategy that a lot of projects end up taking, is introduce the new way, but still have the old way simultaneously.
So it would be like, for example, here.
Yeah. That's a good idea.
Because, unless there is any, but I'm not sure, unless there is any, this is just, this, for example, is a top level interface, because there is, nowhere in the code calls this routine. So this is just top level interface. So maybe we could just, replace, duplicate this, but, not the body of the function, just, the interface. Function as a subroutine is made pure. Function retains the old interface, but the subroutine can internally be called as a pure subroutine. So that enables, the subroutines that call it to make it to become pure themselves. So I think this could be, probably an interesting, both addition, but also a way to make all codes pure. For example, one of the things that I was noticing this week, I've been working on the SVD interface. Now, I'm not gonna deep into this part of the code, but we have the SVD interface, right? Maybe you want the singular values of a matrix. Maybe you want all three SVD matrices. But regardless of that, the subroutine cannot be pure because it's calling this GESDD, which is not pure itself. So, it seems like it turns out, at least for the most complex tasks, those subroutines are not pure. So, maybe it's not very useful to have made, all this work. And the most used parts of the interface are not pure. So I kind of agree that probably it's a useful piece of work that we should, be having. Other questions on the pure interface?
No, not a question, just more of a perspective, at least for me. The things that we're working on right now, you're working on right now, they're meant to be consumed by people. I don't think the expectation of these people are, or at least my expectations are not that, oh, I can drop in um, one-on-one to my existing BLAS or LAPAC representation. So if they work to maintain that backwards compatible interfaces with that duplication is too much, for me, from a product point of view, it doesn't make much sense to invest into them. But again, if they're isolated and there are not many such routines and it's relatively trivial to implement, sure, go for it. Doesn't sound like a costly time investment. But I think the question that we should be asking is: are the people that will be using the linear algebra functionality, the LAPAC functionality from SDLib, uh, expecting to just replace everything they currently have on their existing code and have it to compile, or will they be expected to have some changes in their sources?
It's a very good. It's a very good point, Ioannis, and thank you for making it. To be honest, I'm kind of struggling with the trade-off because what I see is on the one hand, if we can provide robust and basically complete implementations of BLAS and LAPAC, I think you can basically think of never touching that anymore in the foreseeable future, because it's very battle tested code and whatsoever. Now, the reason I'm trying to basically do it this way, and please let me know if you think it's useful, is okay. I understand that maybe in the standard lib style, it would be better, for example, to say, okay, I write my own templated version of a simple function. But the fact that we can use a backend that is compatible with other implementations, I think it's going to be very and dramatically important for the success of the API. For example, I was seeing in these days the Apple MLX code. I was looking at that. So it's basically just another wrapper of linear algebra on top of the Accelerate framework. And so if we are able to keep the same interface as BLAS and LAPAC, standardlib could do exactly the same thing. So we could have the high-level interface that calls the Apple Accelerate framework or OpenBLAS or whatever other, or NKL, or any other implementations without changing any of the high-level code that we're preparing. And I think that would be a very, very important point, because down the road, people are going to look more and more at how fast the code is, whether it can run on the GPU, and all this kind of stuff. So I think at least at the interface level, then what's in the backend, it doesn't really matter that much, because hopefully if you have the external implementation, you can just use that one. But I think at least at the interface level, it would be very important to keep on track and on the same line as some up-to-date version of LabPack, which is what also other frameworks use. What do
I
you
think
think?
that's a very good point. Yeah, I had forgotten about that. Thanks. Yeah, you're right. Same as Brad, by the way, which he posted something in the comments. Yes.
Yeah, sorry, I'm not very used to this GC thing, so I don't see you guys. Let me see if I can put that on the other screen.
Jose, you wanted to comment on that?
Yeah. So basically, taking all of these comments that have been made, there are three. It's kind of in three folds. So yes, stdlib should provide after compilation the symbols to the original functions interfaces. I think this will encourage people to link to stdlib and provide a path, as Richard said, for Brad, sorry, for migration to a more modern interface. It would encourage, actually. For instance, take PetSet. Let's say it's one of the biggest libraries for Krylov methods, and you can choose to link against OpenBlast or MKL or something else. And basically, it simply requires to have the symbols available from a library. So that way, if stdlib has it, it could encourage to compile stdlib, link against it, and then also, as you propose, to have more modern interfaces so that people can safely link against the legacy code and then progressively migrate. If the the available functions are only the modern versions, which are supposed to be better in some sense or safer, it will make it harder for adoption.
Yeah, thank you, Jose. I think it's a very good comment. It's also basically in line with my thoughts on this. The way that I'm trying to come up with so a couple of things I wanted to say. First is I think because of that, and with your help and Jeremy's help, I think the way the interface looks like right now is not too bad, because basically with using this Fortran interface blocks, we have kind independent interfaces to basically all of the LabPack and the BLAS functions. Like take this one for example. This is actually only available in double precision, so maybe let me pick one. Okay, this one here. GBAMV, matrix vector operations, using some methods here. So what it does is, and I'm gonna show you show it also to those that haven't seen that last time. By using preprocessor macros, very simple ones. If you have an external implementations, basically only the interface will be put in the interface block, not the actual module procedure. The module procedure is still available. If you want it, you can call it with the standard lib prefix. If you can go to the module, call whatever version you want with the direct name, but it's not going to be part of the kind independent interface. Kind independent interface will go pick whatever external framework you have. And the interface always also includes the quad precision versions, which external implementations typically don't offer. And so we want to provide, because, I think it's one of Fortran's strengths, for example, compared to Julia, or other languages that, promote that, you can work with different, real kinds. I think it's useful both from the standpoint of usefulness, but also in terms of, completeness of the implementation, that you can run all of these codes with all available real precisions, including those not originally included in LabPack. And as you see here with these guards here, you basically have that, whenever you compile, you can do it in CMake right now because FPM doesn't support FYPP yet, but you can do it with CMake right now. For example, if you want to compile with an external implementation, you just define those macros and link against the external library. So the compiler will go look for the external versions of these functions. But still, you have all the different kinds are always available via the actual prefixed names, which I also found it's one of the requirements of. I'm not sure if the F2C versions that you find in NumPy do it, but I found it's one of the requirements of the LAPACK library that the code is freely available. But whenever you use it or modify it, please rename the routines. So this is one of the things that I have been engineering when preparing this interface. And point number 2 was yes, I definitely agree on the high level interface. The way I'm trying to do it is to mimic what NumPy, SciPy, those 3-4 major libraries do, and try to come up with a version that basically is as similar and as user friendly as possible. And like Jose was saying, the high level API is completely independent of the implementation that you're using. Because, like, for example, I'm showing the SVD here. Okay, the high level API, doesn't have to be necessarily 100% the final version, but the high level API has basically a similar API to what you find in NumPy, SciPy, but internally it's just basically calls to the LAPACK routines. And because the LAPACK interface has been generalized that way, we don't really have to tinker with the code anymore. We know that in our standard lib version, we will need this GESDD function from the LAPACK interface for whatever real kind we're using and whatever implementation we have. And in particular, the implementation will be dealt with by CMake or by the FBM version when that is ready. So I think right now it's like make decisions. Is it worthwhile to spend more time to refine the LAPACK interface and for example to try to make more work to make everything pure and to basically keep improving on it? But that will also slow down the implementation of the higher API interfaces. Or should we decide, okay, this is good enough for now, so let's try to get those PRs merged first? Because once we have an implementation into standard lib, I think then we can start having discussions one by one on SVD, dot products, metrics inversions, determine, all each individual function that at that point, I could start opening PRs for them. But until we have a working, as I said, version 1.0 of the BLAS and LAPACK interfaces into standard lib, it's gonna be hard to create PRs because there's missing code there. Yeah, Jose, I see you raised the hand. Please go ahead.
Yeah. So regarding to what you asked, my opinion would be that do not expend too much energy into the pure making the subroutines pure right now, because if you provide compatible interfaces to the legacy code, and at the same time, let's say, once that's available, then focus on the higher level API, then making the pure subroutines would be kind of an intermediate step that can help make things safer. But I think the added value for the community will be more on the higher level API. And at the same time, making using the std-lib implementation available for other libraries in an easier way. So I think the pure discussion is kind of an intermediate step that could be done afterwards. I don't know what the others.
Yeah, Brad.
Yeah, I think what you've got now is sufficiently stable that probably any changes to add purity in places will be backwards compatible. You're just going to be adding more things, and then adding pure to a subroutine is perfectly backwards compatible with if it didn't have it in the first place, right? So if you're at a place where you're like, okay, this stuff is ready, go ahead and get it merged in, and you can always add new stuff later.
Yeah, I'm also of this opinion. Also agree. If it's ready, and I think it's quite good already now. It's really good actually. And yeah, this pure stuff could be a nice addition, but could delay indeed other things that are I think more important than just this pure stuff. So I would agree also to go to merge. But yeah, what other things? So
Yeah, same. I think it's just push through to get to the high level API, which is where the a lot of the value is held for this.
Yeah. Yeah, I can agree with you guys. I think at this point we should spend some effort to get the base implementation merged, so as to start making more progress on all the other high level APIs. Because there's a lot of interesting work also on the APIs. For example, I was looking at the screen here that in this the SVD version, for example, has a lot of options, right? So you might require some or either some or all of the SVD matrices on output, and I think LAPAC was very well made, so you can share some of the workspace from metrics, from the base metrics, or you can allocate other, or can. So there are several options, and in an expert API that takes all of those options into account to reduce the number of allocations. Uh, it's quite a lot of code. This. So I think focusing on the high level APIs is probably at this point where the background libraries work well, I think is at this point probably far more important.
okay. So what should be the next step to for you, but also for us to help you, or for us, I mean, for the community?
Thank you, Jeremy. Very good questions. So right now, the current state is that I opened 2 PRs. One of them is about the backend and interface implementation. So I think this, they both have the highest priority because the second one deals with the error handling. So if there is any ways that I can help you basically with the review process. I'm not super familiar with the review process in a Standardly, but I believe that 2 reviews are needed for merging. I think. No, I'm mistaken. 1 approving review is required. But anyways, if there is any ways that I could help any of you guys, just take a look at the implementation and just give the green light. Where of course I'm here, so I'm fully responsible for the code. Whatever wrong might happen, I'm here to fix it. But I think it still needs some expert look. One thing that, for example, you might be asking is, have you provided test cases for the implementation? And so I would like to basically show you that what I did is some very, very simple couple test cases, very easy ones for all the real kinds and types. Because ideally, I think it's more important that we put individual test cases, as many as possible, in each of the high-level APIs, which, by the way, call the LAPAC backend. So if the LAPAC backend has something that doesn't work, of course, you got to fix it anyways. But I still put a few test cases and integrated a few test cases for the raw calls to GMV, for example, and the matrix inverse, just to test some of the LAPAC subroutines. Of course, there's hundreds of them, so it's going to be impossible to have checks for each of them. But as I said, I think probably the testing phase is better done in each of the high-level API functions. And then I just final thing that I want to show you is there's another PR, which is oh yes, Janice, please go ahead.
Yeah, what I want to verify is that essentially the reference blast LAPAC implementation that is adding this PR is just auto generated from the repo. So if there is a bug, it either exists in the original BLAS/LAPACK, or more likely in the conversion bit. So again, in the bit that converts it. But so either way, I wouldn't worry too much about that. But the only thing that I want to say is that before we merge this, could we issue a release, which I don't remember how to do, so you might have to help me, Jeremy, to as a like reversion point, the last reference point, because some stuff for numbers to strings or strings to numbers were merged before this, I think.
Yeah, indeed, that was me.
Yeah. So there were some stuff merged around Christmas time,
Yeah,
I think.
you are right. Indeed, and then I can generate a new release before.
Yes, that would be awesome.
I'll
And then we can get this merged. I'll have a look again. And yeah, again, about the testing, I don't think it's like testing the reference implementation. I don't think it's the top priority right now, given that it's essentially a modernized copy that's auto-generated. So yeah, I'll have a look. Oh yeah, the only thing that I want to ask is, can we intend the OpenMP directives, the Sentinel stuff, or is that not possible?
Would you like them indented?
Without massive pain.
So
yes,
see.
since they're part of the code essentially. So I would expect them, since they operate on the code itself, I would expect them to be on the same hierarchy or level of nesting. That
you mean these ones, right?
Yeah.
Yeah. So for this type of symbol, which I apologize because I didn't know about it before. It's basically a guard that you put on every line that you want to run, with OpenMP. So then the line will be indented itself. So maybe I could be indenting only the OpenMP keywords and not those lines that are just are conditional compilation basically. So if OpenMP is, and I think Jeremy, please kick in if you wanna teach us how to use this stuff, because it's the first time that I saw it too. That with this basically comment style, it's basically just conditional compilation that is similar to a macro that defines if OpenMP is defined, and then add this block.
Yeah, you are right. Yeah, I think what Janice asks is to align that with the rest of the code, right, Janice? And not to
yeah. Because I think the first bullet point for the Sentinel says, in OpenMP standard, says the Sentinel can appear in any column, but must be preceded by only by white space. So you should be okay moving those comments further in line with where the code
I see.
they live in.
Yes, it's not a big deal. It's not a big deal.
Yeah, okay. That's it.
Make a note.
I have just one idea. So given that the current PR corresponds to basically the BLAS/LAPACK reference implementation, I haven't checked, but are there any kind of tests out there in GitHub that already test the implementation, such that you could kind of double check with the build and testing with something outside of std, but linking against it? I have no idea. This is just something that came to my mind right now.
It's a very good question, Jose. Actually, I saw that there's a test suite provided by the reference LAPACK. Now, I believe it's this one. Now, however, from a quick glance, it's heavily both pre-processed, and it requires a lot of external files. So in order to integrate this with our implementation of the BLAS/LAPACK would require a lot of work. So This is talking about the actual reference LAPACK. Then there's another thing that I did, which is to look at what, for example, NumPy does, and there is really not a lot of testing. Some very simple subroutines, but they seem to be done on the high-level interface. For example, let me see, NumPy SVD, for example. So if I open the source code, let me search for test. There are some simple tests, but test SVD. All right, test linear algebra here. There are, like you see here, there are some tests, a selection of tests, typically pretty simple ones. And they seem to be done on the high-level interface. So, for example, I don't know, SVD, test SVD, checks for empty input, or tests the high-level interface. Then checks that the results match the SVD. So they don't seem to be having tests directly on the LAPACK implementation, which, by the way, I believe linear algebra, there is a LAPACK Lite implementation, which is, I think it's automatically converted. So it's not, I think they just use F2C or some evolution of it. So what you find in their implementation is actually they're using a pretty old version, 3.2, as a backend for the case where you don't have any external implementations. And we're basically doing the same thing. But I can't see tests which are specifically made for LAPACK and BLES. So I don't know if you have any ideas on how or where I could find other examples of tests that are done directly on the LAPACK routines. I very much willing to add more, which I think that they're useful. But from what I see, attacking the actual test suite of LAPACK, it's going to require a lot of work because it's all Fortran source. It uses a lot of external files, so not very easy to here. Not very easy to basically convert or read, use, and so forth.
Yeah, I think that for this PR is not a problem since we just translate and modernize existing code, so that is used and well known. I don't think it's a problem for now. Shouldn't stop us.
Okay.
Meanwhile, we can look at other implementations, how they do that. So good. Sorry. So yeah, I think that conclusion for this PR is that people should go there and look and review the code, existing code.
Yes, please. To conclude, I would like to just show you real quick. Let me see where it is. That I made a second pull request that is about the state error handling facility. So, please, if you have time, please take a look at it and let me know if you have comments. I think, I already showed, how it works last time. Now I basically parameterize so that it can be pre-processed with FYPP for the types and kinds that are available using standard lib. And it's basically a very simple error handler for the LAPACK routines. I'm going to show that in the here in the editor and state. So what I do is, for example, in this implementation, I don't have templated kinds, so you see all of them one by one. But in the standard versions, these have been templated using the actual kinds that are available using FYPP. And so it's a very simple error handler that contains an error flag and some fixed size strings that contain a message and the location where problems might happen. So what it does is basically it's a fixed size storage. So the compiler probably is very good at optimizing the storage for these variables. And the error handling is done this way. It's all using pure subroutines, since I ported pure here. And basically, whenever the user calls any of the routines, there is an optional output of the error flag. So if something goes wrong and the user requested the error flag on output, then it's just returned as a output error variable. Otherwise, if something went wrong, then just stop the program with the message given by the subroutine. So this gives flexibility that, for example, you don't want to use all these error flags, you just let the code run. But whenever something wrong happens, then the code will stop, which is similar to the original LabPack. Otherwise, if you want to use the more expert interface, then you just, require error flags on output, and then, the code will never stop, but you have to know that, if something went wrong, then you will have an error flag somewhere. I believe, let me see if I can show you the actual implementation in one of these cases. Yes, for example, you want to run matrix inverse. There is an output flag here. There is an optional output. So you can request the error flag, and once you have it, you can check, whatever happened. If you don't request it, you can still call the subroutines without any other additional, arguments, and then that's going to be like if something wrong goes on during the call, then the code will just error stop. So very, very simple error handling, but at the same time should be, flexible enough that it contains, all the possible error types that you can have in linear algebra. What I see in NumPy, for example, is they typically have a few type of errors raised, and you see them here: value error, internal error, or algebra error. This is pretty much it.
Yes. Just maybe one question from my side. Is this PR independent of the other PR?
It is, yes.
Yeah. Nice.
It is, because it's basically only using the constants and the state. This module that contains the state derived type.
Yeah. So yeah, it's easier to review.
Exactly.
Yeah, indeed.
Yeah, as I said, the idea is I want to try to, since well, the previous PR was 500,000 lines of code, but in the next one I will try to reduce the size.
Yeah. Yeah. Any other question or comment for Federico on this one? I think no.
No, I'm good on my side.
Yeah. Okay. So again, I will invite people to go on GitHub and review this piece of code. This one should be shorter to review, I guess. So, thank you for that.
Much appreciated, guys.
And one other question, maybe, when this is done, do you think that this approach would be generalized to a more, let's say, global handling of error types? Or?
I would like it. Because I see that current standardly the error handling facility is relatively limited. Yeah. But what it does is mostly to basically stop the program with a fatal error. So I think it would be nice. And please, if you have this idea, maybe please comment on the PR. I think it might also be a good idea to merge. If this is an idea that is supported by the community, I think it's a good idea in that case to merge this type of error handling with the base standard lib error handling, which is pretty simple so far. There is an error type here. It has not been updated for 4 years, so like you see, it's not super used. But what it does is basically there is just a couple subroutines that basically either check a condition, but stop the program in case something goes wrong.
Yeah, that's very simple. There's been quite a lot of discussion on that, never agreement. So yeah, you propose something, people can review and test it and play with it and see how it goes. So that's
right. And this doesn't, this means that maybe if linear algebra error handling works well and other people like it, maybe in a second time later we can generalize that to the whole of standard lib. Since there is not a lot of error handling done yet.
Sure. Sounds
Great.
Sounds good. Okay, from my side. Any other question? No, for that.
Yeah, just one last and maybe kind of provocative one. The last time we talked about a half precision, and this is just curiosity. How easily would it be to take the FYPP version to generate a half precision version of the codes, given that you kind of did it for quad precision?
So super easy, because the way it's done from double to quad precision is basically just renaming variables and kinds. That doesn't change the internal allocation sizes though, which for quad precision are going to be the same as for double precision. I think it's ILA environment, which is in a LabPack, I believe. This function basically for most of the subroutines decides what the block size of the pipelines, decides a lot of sizes for each of the for most of the implementations. So as I said, in this case, the quad precision uses the sizes for double precision, uses the same values. If you're gonna use 16-byte version, 16-bit version, I think maybe it's not a big deal. I don't know, because you already get speed out of that using the lower precision. But you could, in theory, just pick one either of the modules. For example, the quad precision one, and instead of using QP, you use another type of kind, and I think you're done. Instead of using quad precision, for example, you use half precision, and you should be done. There is only a couple subroutines that are so far they're manually handled, and they basically handle the conversion between kinds. Let me see if I can spot them. This is, for example, a duplicate. I think there is leg2, qleg2s, for example. Yes, this converts a quad precision matrix to a double precision matrix. So you might want to take a look at the subroutines that use this mixed precision. Of course, if you're going to use half precision, you're not going to have this available. So you want to check them. But it's a very limited effort.
Thanks.
Yeah, you're welcome.
Okay, thank you. Yeah, I think it's almost time to close the meeting, just to be on time. Any final question, comment?
No questions. I just want to say that we should be finishing soon the GSOC contributor period. I don't remember the name. It's on the timeline schedule. And I think we should start reviewing proposals soon-ish. Those of us who have students or projects. Anyway, that's it.
Yeah, great reminder. Yeah, thank you. Okay.
Yeah, no worries. I'll send another message as well. Okay. Okay.
Janice, please, can you tell us when is the deadline for the closing of the applications?
Give me a second. I'll send the link as well. Jesus. Okay. So So applications, so the application period began on the 18th of March. It finishes on the 2nd of April.
Okay.
Contributors have to be ranked by 24th, and they will be announced by May 1st. So let me post the
Okay.
link as well in the chat. Okay.
Okay.
Okay, awesome.
Okay, thank you. I think that now we can close the meeting. Thank you all for attending it. Thank you, Federico, for your work and presenting it today.
Yes.
Thank you, everybody,
Yeah.
for attending. Much appreciated.
Yeah. Thank you, and
Thank you, guys.
good evening or good day. Bye.
Thank you.
Have a
Bye
great
bye.
rest of the day, guys.